Okay, so we have, so today we're going to talk about, for Saxon, lesson 11, and it's basically reciprocal and multiplicative inverse, and then order of operation. We're going to first deal with this and then that, okay? So what is a reciprocal? Who knows?
It's a thing.
What?
The opposite, I'm pretty sure.
Like, give me, so what's the reciprocal of 1/2?
2/1.
Yes, okay. So reciprocal,
Oh, it's like another name for
opposite
thing.
For opposite.
Okay, no.
there we go. Reciprocal of a fraction, well, let's see, of, well, sure, a fraction is the
Flip, I guess.
right, is the flip of the fraction. That's, I don't know. I wasn't going to say it this way, but all right, so, but that's okay. So if I had 2/3, the reciprocal is 3/2. If I had -4/9, the reciprocal is negative. It still is negative, but then you just flip it, right? 9/4. Right? So you guys are clear on that, right? You guys have probably all learned this. Am I right or wrong? You've all heard the word reciprocal, have you? Okay. So it's pretty clear, right? Pretty straightforward. Yes.
Like, so if you need to, if you need to reciprocal something, is it called reciprocation? What is it called? If you need it to do something, if you need to do that to something, what would you call it?
Reciprocation? I don't know.
Like, would you say?
I would just say,
reciprocate?
Separate.
I don't know. I've never heard that.
Just the reciprocal.
It's a good question. I don't know. I've never heard anybody say it that way. I mean, I'd probably say find the reciprocal.
Yeah.
You know what I mean?
Well, it's like you need to reciprocate this problem or something like that.
Well, yeah, it sort of makes sense when you think about it. I mean, if somebody does something nice for you, you reciprocate and do something nice for them, right? The only problem with that is it sometimes seems like it might be the same thing. Whereas in math, they're clearly it's actually called the inverse.
Like,
so,
say if you're writing down a problem, you write down 3/2, and then when you're correcting,
right.
you need to say reciprocate
right.
this number or something.
Yeah. I don't know, but good question. So what number does not have a reciprocal?
0.
Oh.
Say what?
0?
0. Let's think about it. If I have 0/1, right? Is that okay to have 0 in the numerator?
Yes. Oh wait, no.
Is it okay? Is it okay?
And it becomes
Yes.
Alright, then it's just.
Yes.
Okay, wait. How many people? Let's have a show of hands. Is it okay to have 0 in the numerator? Raise your hand if you say yes, it is okay.
Yes.
All right, raise your hand if you say no, it isn't okay. All right. Now, if 0, okay, this is really an important thing. If 0 is in, God, I can't read my own writing. I'm going to just put 0, spell it. If 0 is in numerator,
It's okay.
it is okay. It is okay, and it equals 0.
If you
But if it's
divide
0
by
over any number
that's
equals 0.
But if it's 0
But-
over, if it's something over 0, then it's
undivided.
But if
And if it's 0 over
0 is in the denominator not okay. It doesn't even equal 0. It doesn't equal 0. If you had, so this is for this, right? But for this, if you had 3/0, that is called undefined.
But Undefined.
Isn't it when
Undefined.
it's 0 over 0? Isn't it like indeterminate? Called indeterminate?
Indetermined or undefined. Undefined is usually the word
I
they
know,
use.
but it's 0
but-
over 0 is an indeterminate.
Oh yes, right. 0 over 0 is not, it's indeterminate, right? There's no, this is not 0. 0 over 0. 0 over 1 is 0. 0 over 2. 0 over a million. 0 over a billion. 0 over a trillion. 0 over a Google. 0 over an Aiden is a 0, right? But Aiden over 0 is undefined, right? You can't have any number. You can't, it doesn't matter what the number is. If 0 is in the denominator, it's undefined. Notice here, 0 is in the numerator, but it's also in the denominator. And you'd think, well, 0 divided by 0 is 0. Well, not necessarily. How many zeros can you get into a 0? I don't know. Nobody's ever been able to figure it out. Right? It doesn't work. So this is indeterminate, right? This is, I guess that's fine. I'll use that word. Indeterminate. It's, but this one, the way I remember this is, this is the fraction line, right? If 0 is under the line, it is undefined. Under the line, undefined. Under the line, oh, that rhymes. Under the line, undefined. Yes.
I know which number cannot be reciprocated.
Say it one more time.
I know what number
Okay.
cannot be
Which is what?
1. A negative 1 cannot be reciprocated because you have
Well,
5
well,
over
1 over 1.
Yeah, 1 over 1
Right.
would be 1 over 1. And then
Right. Then it would be the
5
same
would
1
be
over.
5 over 5.
Yeah.
It'd still be reciprocated.
But you could still put that one upstairs and that one downstairs.
I don't know,
Yes,
it would
but
still
you
be
can
1.
never
But it would
tell
still be
which
1. Right. Right. Now,
It still
Okay.
doesn't matter.
See the
all right.
wait, don't erase it.
All right, so now we're going to the next step that you have to understand. Now, notice the topic. It says reciprocal and multiplicative inverse. That's kind of a mouthful. Multiplicative inverse. Say that. Multiplicative inverse. Multiplicative inverse. All right?
What does that mean? Is it even a word?
A reciprocal is also considered an inverse. It's actually considered a multiplicative inverse, right? But it's actually an inverse. And then, but when you're multiplying, go ahead.
Okay,
Yeah.
so is like reciprocal another name for like opposite? Or like inverse?
Inverse. Reciprocal and inverse are often used
Inverse is like
interchangeably, right? But the reason they're saying multiplicative inverse is because they often call it that when they say something. If, this is a big rule. Rule. Really important. Really helpful rule. If you multiply, so you should write this down as I'm writing it. If you multiply a fraction times its reciprocal,
It equals 1.
right, it equals 1. Okay? It equals 1. So let's think about that. 2/5 times. Now its reciprocal is what? 5 over 2. 5 over 2. Now you could do the old-fashioned way, which I don't like, which is to say 2 times 5 is 10 over 5 times 2 is 10. You could do that way, right? 10 over 10. And 10 over 10 is equal to 1. But I like, what's the way I like? Upstairs, downstairs, cross-reducing, whatever, right? So 2 goes into 2 once, 2 goes into 2 once. 5 goes into 5 once, 5 goes into 5 once. 1 times 1 is 1 1 times 1 is 1. 1 over 1 is 1. Right? Right? They're the same thing. But it always works. Any fraction, if you multiply it times its reciprocal, right? It will equal, so Sevi, you have to have your notes out, buddy. You have to, everything that's on this board you have to write down. Okay? It'll help keep you awake. Trust me. It will help you keep awake.
The definition of a reciprocal from the book is for any non-zero real number, the number is inverted form.
Say it again.
Wait, so the definition of reciprocal in the book is for any non-zero real number, the number is inverted form. Inverted.
That's good. The inverted, the flip of the fraction, or the inverted. Yeah, I like that word inverted better. But this always works. Now, a lot of times they'll talk about the multiplicative inverse. All it is reciprocal. And they usually say it in terms of, well, multiply 2/5 times its multiplicative inverse, right? In other words, you're multiplying it times the inverted form, right? Therefore, it's the inverse, inverted inverse, right? All right, so that's it. Pretty straightforward, right? There's not much more to say about it, right? So now I'm going to move on to order of operations. Can I erase yet?
Yeah.
You've got to still copy a few things. Quote of the day: when spider webs unite, they can tie up a lion.
Oh, I read that story.
Ethiopian proverb. That's cool.
It was like a rat.
I was going to try to erase it, but I don't think I will.
Took down a lion and he put the rope over it and stuff. Yeah.
Can I erase?
Williams.
Oh yeah, I've heard that.
Yeah.
Very happy about this.
So in this chapter, order of operation, that's what we're going to talk about now. Order of operation is really, really simple. But they get really, really complex really, really fast. So in this chapter, they're not complex. But they do get complex. But order of operation. Order of operation. Most people talk about a thing called PEMDAS, right?
Oh yeah.
PEMDAS.
Please excuse
Right?
my ignorance.
Please excuse my dear Aunt Sally. And there are other ones too, but I don't remember.
Did you memorize that?
Right? And so P stands for what? Parentheses. So guys, write this down. E stands for
Exponents.
exponents. M stands for multiplication. D stands for division.
Add, subtract.
Add, subtract. Right?
So, okay.
So, where are your notes? Should we take your notes?
Oh yeah, no, it's just hard to write in my binder. Can I put them in my binder when I'm done?
Oh, are those your notes?
Yeah, it's just hard to write in my binder. It's not a flat surface.
Those are notes? Okay. All right. So order of operation, parentheses, exponents, multiplication, division, add, subtract. Now, usually when it's first taught, it's taught that you do parentheses first. So you look for something with parentheses, and you always do with parentheses first. Second thing, you try to do inside the parentheses, right? You try to simplify. Second thing, exponents. So if there's any exponents, it's the second thing you simplify. And then you go to multiplication and division. But there's a rule about the multiplication and division. Does anybody know what it is? Thorn?
Isn't it like if there's a division problem in front of the multiplication, you still do the multiplication problem?
Actually, it's just the reverse of that. You will actually go from left to right. So if it has a division problem first, you will actually do the division problem first.
Oh,
right? It's whichever shows up from left to right. From left to right. Okay? And then once you've done all the multiplication and division stuff, then you have add and subtract. And the same rule is true for the add and subtract. You do from left to right in the problem, from left to right. So that means if there's a subtraction first, you do the subtraction, right? And then if there's an addition later, you do the addition. Or if the addition is first, you do the addition. From left to right. Now, does anybody know why this is important? What if I did this? What if I said 9 minus 4 times 5? So, if I had two different people, right, and they just decided, okay, well, 9 minus 4. So the first person might do it this way. They might say, well, I'll write it again. 9 minus, this is the first way. 9 minus 4 times 5. Well, 9 minus 4 is what? 5. So that's 5 times 5. So what does that equal?
25.
That equals 25. So that's person number 1. Person number 2 comes along and they do this. They have 9 minus 4 times 5. They say, well, I'm going to just multiply these two first because I know 4 times 5 is 20. So I got 9 minus 20. Uh-oh. What's that equal?
Negative 29.
Negative 11.
Negative 11, right?
That doesn't make sense.
Is that right? 11? I think it's negative 11. Negative 11. Well, that's interesting. I mean, it seems like they both did, like, appropriate stuff, right? Right?
The first one.
Well, the
Well,
second one.
technically, both ways work. I mean, both they're valid. The only thing is, if everybody used a different approach, math would be almost non-existent, right? Like you wouldn't be able to know what people are solving for, right? So they had to come up with rules. I'm sorry. Sorry, I'll stand over here. They had to come up with rules so that everybody would get the same answer every time, right? Because otherwise, if you just randomly chose which one to do first, everybody would get it. You know, I could actually do a complicated one up here, and there could be like 7 different possible answers, you know, depending on which thing you decided to do first, right? And so we have to all abide by certain rules, and that's what this order of operations is all about. It allows us to create, you know, to solve a problem and always get the same answer, right? Okay. Did somebody have a question? No? Okay. Can I erase that part or this part? Well, I better keep that. Can I erase that?
Yeah.
All right. So let's try some. Sometimes you will see. Well, let's see. Let's just try it. Let's try 4 times 6.
Can we do this by ourselves?
Plus, sure, negative 2 times 10. Okay, do that real quickly. So write it down in your notes and actually do it. Okay? Yeah. So parentheses, I'm going to write that down right here. This is so important to remember. Parentheses always means multiply.
Yeah.
Right? So I'm throwing that in there specifically to make means multiply. Always. In math. All right? So I see, I got 4 times 6 and then plus, and then I've got a negative 2, parentheses, and 10 parentheses. So, yes, Thorn.
Is the answer just 4?
Correct.
Yeah, in my head!
So, I wouldn't deal with the plus first. I would deal with the multiplying first, right?
Yeah.
Now this says parentheses, right? Now, does that mean I have to multiply these first? Because technically, when they say parentheses, they're saying if there's something inside the parentheses that you can do.
Yeah. If there's a problem
Like if
with
it was like 2 plus 3, plus 7 times 1. I would have to do this first. That's 5. You see what I'm saying? But there's nothing I can do inside this parenthesis. So really, that's all they're talking about. Parenthesis, in this case, they're talking about inside. Okay? And so it doesn't really matter, but usually you go left to right. This is a multiply, 4 times 6, and this is a multiply, -2 times 10. That's what parentheses mean, times. So 4 times 6 is 24, plus, and then -2 times 10 is -20. That's the same as 24 minus 20, which is just 4, right? Okay, let's try another one. So that was number 1. Let's try number 2. Let's try, where are we? Let me think, where am I? Okay, 5 minus 7 times 2 plus 6 minus 2 times 1. All right, so do it.
You got this.
So the first thing you look at is parentheses. Is there something inside of parentheses that you can simplify? What's 5 minus 7? -2. I'm going to keep it in the parentheses though. What's, okay, times 2. Okay, plus 6 minus, oh, there's another multiply. What's 2 times 1? 2, right? Okay, now what's -2 times 2?
Zero.
No. That's no.
That's -4.
Yeah, this is negative. This is multiply. This is -4. Plus 6 minus 2. Now I go in order. 6 minus 4 is 2. Minus 2, it's 0. Okay? Make sense? All right, so that's basically it. Homework tonight. So get out your planner. Yeah.
Is it left to right like do multiplication and division before subtraction?
Yes. Yeah. You do all the multiply and divisions first, and then you do all the add and subtracts, right? Okay. So lesson 11 on page 53. You're going to do practice A through D. Make sure you all do practice A through D. Those are practicing specifically this lesson 11. Lesson 11, page 53. Practice A through D. And then problems.
Problem set or problems?
Problem set. Oh, sorry. Let me think. 1 through, let's just do 1 through 6, and then all of them, 1 through 6, and then let's do 12 through 21.
All?
Well, yeah, sure. Because they're pretty easy, I think.
No. Would you they're not in?
Well, let's say, okay, let's just say 12 through 18. 12 through 18.
Okay, that's good.
Okay?
Awesome, Gary.
All right, that's it, guys. Thank you.
Thanks for